And Kris, take it away.
Okay, hi, good afternoon, everybody. Like Patrick said, my name is Kris Ribble. I work for NRCS. Some of you might know us as SCS, the Soil Conservation Service, but we're now called NRCS. And we work locally here in Columbia County, as well as we cover Montour County, working with farmers and private landowners to look at resource concerns on all kinds of land uses, ag land, forest land, pasture land, you name it. We can come out to the farm voluntarily and take a look at what's going on there and talk about your goals and objectives and figure out what kind of conservation practices might help solve resource concerns on your land or your farm, as well as what are any program opportunities that could be available for you to help solve some of those things, at least with some financial assistance. So what Brittany asked me to speak about today was soil health. And I was going to take a look at it as far as soil health in our local area and how are farms using soil health and improving soil health and what are the benefits of doing that. Now, keep that in mind. Brittany said that most of you, she thought today, were not necessarily farmers. I'm not sure, maybe some of you own farmland that a farmer farms for you or rents the land from you. If not, any of these principles of soil health that we talk about can apply to really to forest land, to gardens, yards, you name it. These are biological principles that will improve soil health basically anywhere at any time if you apply them and think through how the biology and these principles apply to your particular system. So most of my background and my examples will be from an agricultural standpoint, but you know, like I say, these principles will apply. So I'm going to turn my video off just because I don't have the greatest connection in the world, and we'll go from there. So Soil Health 101, what are the opportunities for soil health for us here locally where we live and work in our local watersheds? So here, the question that I pose is, can we fix all of our problems with technology alone? You know, think about that. We live in a very technological age. We have an app for everything these days. We use the computer quite a bit. A lot of things are automated, but is that really the best thing? Can we do that? I found this this cartoon a while back, and you know, the two farmers are standing there, and they say, I think it was a mistake to go wireless. I don't know. Any of you that have livestock or have been around cattle, this is a pretty big mistake. We don't want to go wireless in this case. So technology can't always solve things. Sometimes it's just basic principles, and that's a lot of what soil health is, just using these basic ecological principles to improve our soils. So, you know, do we always need that technology, or can we adapt and change the way that we manage our farms? So then I asked the question, what is soil health? We hear this term a lot. It's kind of like a buzzword. It seems to be in a lot of the ag publications. I think we're starting to see it in watershed group circles and even within science classes and those sorts of things with our kids at school. But what is soil health and why is it important? And I love this photo because if you really take a look at this photo, think about, you know, what jumps out to you in this photo. Patrick, can you guys see my mouse or not?
Yep, I can see it.
You see the mouse?
Yep.
Take a look at the loss of soil around this electric pole here. Look at the loss of soil. They're farming up and down the hill. They're using a lot of tillage. There's a lot of brown, bare earth there. They've got a lot of clods and things to me that are showing degradation in soil. On the downhill side of this, I don't know if this is an area that's been plowed or whatnot, but there's obviously been a ton of soil loss over the years there. So why is this soil health important to us as people that live in a watershed, community members, farmers, people that consume food, whatever part you fall into? So let's start by defining what soil health is, because it can be kind of this nebulous thing that we're not exactly sure what it is. We've heard the term, but we're not sure what it is. Here's Penn State's definition. This came right out of the Penn State Agronomy Guide, and I like this definition. It says soil health is defined as the capacity of a soil to function within an ecosystem boundary to sustain biological productivity, maintain environmental health, and promote plant and animal health. And then it goes on to say that soil properties that determine soil health include the physical properties, like the structure, the bulk density, chemical properties like pH and those kinds of things, and then your biological properties. And we deal a lot with the biological end of soil in the soil health arena. But when I whittle all that down, that big wordy paragraph, essentially soil health is the ability of your soil to meet your needs as a landowner, as a farmer, as a gardener, as a forest manager. Your soil is healthy enough biologically and sustainable enough that it can meet your needs to produce whatever the product is you're producing in an environmentally friendly way. So here's two pictures. Think about for a minute what you think that might be, and then I'll tell you. I'll give you just a second here to look at it. So these are two counties. This is Columbia County on the right, and this is Montour County, okay? And I asked the question, do you own farmland in Columbia or Montour County? Or for that matter, do you own or manage open land of any kind, yard, garden, forest, or whatever? What you're looking at is essentially all the streams in Columbia and Montour County, and then these areas here, these like blue-gray areas are buffers that I put on those streams. So those are, I think, 100-foot buffers either way of either side of the stream. So what struck out to me when I put this map together was, wow, we all live and work probably in pretty close proximity to a stream or a water body and can have an impact somehow or another on that water body as far as how we manage our land. So we're loaded with streams here. So chances are we're potentially part of the problem and maybe part of the solution all at the same time. You know, and I started to think about, well, why is this important to me? And this picture came to mind. Anybody remembers back in 2011, the big flood we had, one of many. We had a flood in August of 18, we had one in 96, 06. It just continues to happen. And we're probably not gonna stop floods, but maybe we have the ability through management to reduce the amount of flooding, you know? So there's the fairgrounds in the Susquehanna River back in September of 2011. Really mass inundation and damage to homes and businesses. And we wanna see if there's something we can do about that to avoid it. And the more I learned about the soil health, the more I realized that, man, healthy soils can really make an impact on this. So let's talk about what are some of the causes of flooding and erosion in the area where we live and what we live. And then let's take a look and discuss farms and soil health and how they can impact those things. So if you have farmland or you drive around and you see farmland or there's neighboring farmland, or maybe you see some of this on your own property, do you see any of the following things? In this circle here, you can see we have what we call rill or gully erosion. So small little gullies, something like 1 to 3 inches deep. They're on the hillside and they're just kind of coming down in finger-like patterns. Just little bits of erosion on sensitive areas, concentrated flow areas and whatnot. This could be an indicator of poor soil health. It's probably saying to us, there's something we could do differently to manage this land to keep soil in place and improve the health of the soils. Do we see crusted soils? You can see in this instance here, if you look in there, look how crusted and sealed over the top of that soil is. When that happens to a soil, it doesn't infiltrate a whole lot of water. As soon as that crust forms, it has a tendency to create a runoff issue. The water is going to run off of that soil surface and take soil with it, creating sediment issues. Do we have gully erosion? Look at the erosion coming out of this crop field here. There's literally small gullies washing away the soil from the roots of these plants. This happened to be along a roadside I saw in a different county in one of my travels. You know, and then do we have ponded water or runoff actually coming off of these fields? Now, this doesn't have to be a field. This could be your yard. This could be a driveway. This could be your woodlot. But again, here we have a soil that's really degraded. It's got a lot of surface crusting. It has poor infiltration characteristics, and water's just literally running off this, taking soil and nutrients with it. Or do we have compaction? A lot of the modern machinery and the methods that we use to farm land today cause compaction down in the 3 to 5 inch zone and sometimes in the 8 to 10 inch zone, and it doesn't allow soils to come through. This particular field here, we ran an infiltration ring, and you notice when we pulled that out of the ground, the soil was so compacted, the wedge of soil was still in the bottom of this, and water wasn't even coming through, and it was just as dry as could be below. So that compacted layer is really keeping water from infiltrating into that soil where we want it in the root zone for plants to grow, and also to filter that water and allow it to filter through the soil and not go directly to the stream, which makes our flooding issues more severe. And then, we've all seen this probably after a stream. This is a stream on my way to work. After a large rain, it's just chocolate brown. I hope in time this will get better, but we still have a lot of work to do. And some of the things we're going to talk about today as far as improving soil health, I think can have a direct impact on all of these things to address all of these issues. Here's just some more indicators or things that you might see where soils are not healthy or where the health of the soil could definitely be improved. So over here at the top left, we've got gully erosion. You can see the soil washed away and water flowing down through there, crop residue and soil going with it. Below it is an example of gully erosion where water's concentrating in a depression. The soil has very little surface cover. It has poor aggregate stability, poor infiltration, and a gully forms. Now, gully's, something 6 inches deep or more. And we see this a fair amount in tillage systems or even in no-till systems without cover. Here's some more examples of real erosion, just that smaller 1 to 3 inch type gully, but you can see the damage occurring. Here's the aftermath of areas where you have tight soils, compaction, just poor aggregate stability and sealing and crusting. Look how poor the crop production is in those areas, and water is going to run off of those readily. Again, examples of real erosion, you can see them here in the field. Up here, you can see them tailing down through there and depositing soil. Overgrazed pastures, we might not think about that, but overgrazed pastures can have a tremendous amount of compaction. They can have surface sealing and crusting, and they don't have a lot of soil armor on top of the soil to deaden the impact of the raindrops as they hit there, and we can get a fair amount of runoff off of overgrazed pasture. So pasture can also be a place. We think a lot about crop fields, but pasture is also a place where we can improve soil health through the plants we grow and the management of those plants and how we graze them. Just some other examples of this stuff. Here's a field here where a farmer had actually used some cover crop, but then they went ahead and tilled it. And the soil really is not tremendously healthy to begin with. And just look at the surface crusting there and the amount of water that had run off this field or is going to run off it in all these tracks. These are all indicators of poor soil health. The soil is dried and cracking. The plants can hardly come through there. It's obvious that soil's been running off of that field. So there are things there we can do to improve it. Here's just a picture of some of the compaction that we see in this same field below there. This compacted zone between these two red lines here is in the 3 to 5 inch layer. And we find this quite often where tillage equipment's used. Where the bottom of the tillage implement rides, you find this compacted layer. And what happens is the surface soil, the soil on top of that gets really, really wet. And there's that compacted zone below the surface soil. When there's any kind of grade and the water keeps coming, it will wash that top layer off and cause severe erosion. So by combating compaction, we can get more water in the ground and really help to improve the health of our soils. Poor soil structure. Whenever you see these big clods, big masses of soil out there in the field that have to be beat down with tillage equipment, that's always a sign of poor aggregate stability. There's not a lot of biological activity in that soil. There's not much natural glue in there. There's a product called glomalin that's produced by earthworms and plant roots that actually helps to aggregate that soil and have lots of space for air and water to infiltrate. But again, these big hard blocks of soil like that are indicators of poor soil health if you're seeing them driving around the countryside. Living roots. Do we have living roots out there in the soil? They can be a beneficial thing. So now we're kind of getting to the tail end of some of these negative soil health indicators or poor soil health, and we're moving over to the positive soil health attributes. Like how can we start to make this transition and improve our healthy soils? One thing we want to focus on is having living roots in the soil. This is a rye plant, rye cover crop. It's probably only 3 inches tall, but look at the amount of root hairs down through there and how it's starting to break up that soil and create these little aggregates or these little balls of soil attached to there. That's that soil glue, the glomalin that's being created by the biology in that soil to hold these little aggregates together to help us improve aggregate stability and infiltration capacity of that soil. Soil armor, we want to protect that soil surface because when the raindrop impacts the soil directly, it has a tendency to want to loosen that soil particle and take it with the water and off of the field and create erosion. But if we can armor that soil, like in this case here, you've got rye cover crop residue there. When the rain comes down, it hits that cover crop residue instead of the soil directly and kind of drizzles in there and deadens the impact of that. Again, lessening erosion. The cover crop residue can also keep water in the ground in the summertime when it's hot and dry, where it would have evaporated otherwise if there was no cover. And then here's something that's becoming increasingly more popular. This is a cornfield, grain cornfield, and they have seeded cover crop in this late in the season, like up to Thanksgiving and first part of December. People keep seeding this, and it doesn't look like a whole lot. You can barely see the green rows in here, but they are there. That rye is getting hold and it's creating a nice big healthy root system, and it's helping to tie that soil together. And come spring in February, March, and April, when the temperatures start to warm up, that'll grow rapidly and help to protect our soil and feed soil biology. And then here's just a diagram. This is from some research done in the 50s on pasture, but I really liked it. This shows 4 different pots full of pasture grasses, and it shows different levels that they have clipped these grasses. Okay, so this one's been clipped pretty short, kind of intermediate, in between that, and then just left to grow. Notice the root system on these plants. Okay, this is the key to soil health right here. Okay, healthy soils are built by big healthy root systems, because as those root systems die back each year and the microbes and the soil biology chews them up, incorporates them, and makes them part of the humus or the organic matter of that soil, it really begins to improve the soil health overall. If any of you folks have a yard out there and it burns up in the middle of July and August, think of this picture. If you cut your grass really, really short, the plant says, I need to survive. I need to sustain myself. So what does it do? It cuts back on the root biomass so it can maintain, because there's not a lot of water. But then what happens when it's hot and dry? It can't go deep for water, can it? But if we leave a little more residue out there, and this applies to pasture management, look at the difference in the root system where it can go down in there and get water. This is the same for crop field or pasture or your yard. Leave a little residue on top, you're going to have more of a root system, and you're going to have much more resilient plants and soil in the long haul. Okay, here's just some more resource concerns and things that we're trying to combat as we're improving our degraded soils and turning them into healthy soils. This is a soil surface. We took a shovel and dug out a hole, and here's the soil surface up here. You can see a radish plant, and you have some decent soil in here. You can see these little balls of soil. So those are called soil aggregates. They're held together by that glomalin, that soil glue. Look at the root hairs coming through here. But you'll notice that the soil broke right here in this flat plane or this plate, and you can see some more of these plates in here. This is called Platy Structure, and that's an indication of soil compaction in there, probably from machinery and management in the past. And again, that's in that 3 to 5 inch zone. So as this soil surface saturates and it hits this compacted layer, it's almost like a sheet of glass. The water comes down, it can't come through it. And wherever there's a grade, this soil has a tendency to want to wash off the soil there. So with covers and soil health principles, we want to try to biologically break through those compacted zones and increase our infiltration and improve soil health over time. Here's a cover crop plant that we can use to combat poor soils and make them more healthy. This one is called a tillage radish. It's a daikon radish. They plant them out there in the late summer and let them grow into fall. And the bigger that tuber on the radish gets, it's an indication of the more nutrients that it's uptaking. So if there's leftover nitrogen or potassium or phosphorus or any nutrient for that matter, the radish is sucking that up and it's storing it in the biomass of the tuber here. the top growth will fall kill. And then this nutrient will be broken down by frost and by the soil microbes, and your grass cover crops here can uptake that nutrient and hold on to it until the following spring when the next crop can use it. So this is another way we're able to make our soils more resilient by hanging on to excess nutrients out there and also helping to alleviate compaction to improve the health of those soils through the use of cover crop plants. So what are the benefits of improving soil health, both locally and at the watershed scale? Because there's a lot of benefits to improving the health of our soils. And the first part is why I went through all those different slides. The first part is identifying, do I have healthy soil or not? Okay. And if you don't know if you do or not, there are folks out there like Patrick and myself from some of the conservation agencies and the agronomists that can come out in the field and look and help you determine that. But let's talk about what these benefits are of improving the health of our soil. One, we can improve the infiltration of our soil. As we improve the health of our soil, we can reduce things like compaction and decrease the bulk density of that soil. And we can improve the aggregate stability, so it'll give us more open pore space for air and water to infiltrate into that soil. I noted here, as we improve our infiltration, we can potentially reduce the impacts of flooding, because the more water we get into the ground to infiltrate up high in the watershed, the less water that runs down and runs directly into that stream, which causes that flood surge in a storm event. We can increase carbon sequestration. This is a key concept. Carbon sequestration, there's a lot of talk out there about global warming and high carbon dioxide levels in the air. Plants and the soil, aside from the oceans, is the second largest potential sink for carbon that exists today in the world. And plants can take carbon dioxide out of the atmosphere and store it in the soil. It's pretty simple. It's a complex process biologically, but by growing green plants, we can put carbon, take it from the air and put it in the soil. This concept is key, though. The key part of this, is that we have to feed our soil microbes, because they help drive this system. If we don't feed the soil microbes, our soils won't improve and become healthy. And soil microbes, if you knew it or not, their food source is carbon. We have to put carbon in the ground, and we do that through growing green plants. We can improve our nutrient cycling in the system. There are a ton of nutrients and fertility locked away in our soils already that aren't necessarily available to the plant. But when we feed that microbe community, that herd underneath, by things like growing covers and having green plants and feeding that microbe health, that microbe community down there, we can cycle those nutrients within the soil and put them in a plant available form that now our plants can use them. So there is a possibility over time, as you improve the health of a soil, that we can back off on commercial nutrient usage just by improving the health of the soil and allowing our microbes to work for. We can improve the water holding capacity of the soil. And by doing this, by allowing that soil to hold more water, it minimizes those impacts that extreme weather like drought would have on our yields, on our crops, making our systems more sustainable and resilient. Because right now, the two biggest reductions of yields to crops out there in food systems really are extreme drought and extreme wetness. And we can manage to a degree both of those with healthy soils and cover crops and no-till systems. And then finally, we can reduce runoff and storm impacts, and again, flooding impacts. There's a agronomist used to work for NRCS by the name of Ray Archuleta, and he had this saying. He would say, we really don't have a runoff issue, we have an infiltration issue. And I think he hit the nail on the head there. Our lack of infiltration in our soils is causing excessive runoff, and we can fix this lack of infiltration by improving the health of the soil, and who knows, maybe even impact our local ecosystems and our watersheds by reducing flooding. So let's talk about conservation practices and how they lead us down this path to healthy soils. So how do we get from a degraded soil, like we saw in some of those pictures that had surface crusting and it had erosion and it had compaction and lack of soil biology, how do we get from there to a healthy soil that's going to work for everyone, for the farmer, for the consumer, for the neighbor of the farmer? just a brief discussion about what are some of the current things out there that might be causing some of these degraded soils. No doubt about it, tillage has an impact on the health of the soil. Tillage tends to break down the aggregate stability of the soil, the structure of the soil. It tends to decrease the amount of organic matter in that soil, and it has an impact on the soil biology as far as how active and healthy that system is. So at the top left, you'll see a moldboard plow. That's an older technology. There's still some of that done in our area that turns the soil completely over and leaves a lot of soil exposed to impacts of rainfall. There's a chisel plow, which is down here at the bottom. That does more of a vertical mixing than totally inverting the soil, so it leaves more residue on top. It's a little better. And then you have a disc or vertical tillage machine. There's all kinds of variations of this. They do a little bit less disturbing and don't go as deep, and you can see it leaves some residue. So I've mentioned surface residue quite a bit and how erosion occurs when raindrops directly impact the soil and dislodge the soil. So here's just an example of what residue cover looks like. The top left corner is 10% residue, and we talk about residue amount left after the planter has gone through the field. So you can see 10% residue here. Looks like not very much at all. Here's a piece, there's a couple over there, but not much. A lot of exposed soil that's susceptible to erosion and the impacts of rainfall. Here's 30% residue. There's a little more. Generally 30% or more is considered a conservation tillage measure. So you've got some soil surface protection by this dead corn residue. At the bottom left here is 60%, a little bit more. And then here's the kind of things on the bottom right that we're really starting to get into and see more of in these healthy soil systems where people are making big improvements in soil health. What you have here is corn and soybeans both no-tilled into old crop residue, as well as this corn on the right was actually planted into tall rye that was killed off with a herbicide. And now look at all of the residue amount on top of the ground. You have to protect that soil surface from the impact of raindrops quite a bit. So residue is key to building healthy soils. Here is just an example of some structural and land-based conservation practices that NRCS or SCS has been doing literally since the 40s. On the left is what we call contour strip cropping. So we lay the direction of tillage or farming or planting those crops out on the contour, and we vary the width of those strips based on the severity of the slope and what kinds of crops are growing. And that can have a big impact on soil erosion and the amount of water we infiltrate. In the middle are some other structural practices where we build grass waterways and cropland terraces, in other words, structures that sort of catch runoff coming down the hill and safely move it to one centralized seeded grass low area or waterway that can safely remove the water from that area and limit the amount of erosion on a field. And then on the right side there, we have numerous examples of where folks have put in grassed field borders along the edge of streams there. You can see there's a stream running down through this green area in the middle. It's already got some existing tree and shrub vegetation, and then the farmer added an additional tall grass border here to filter nutrients and provide added benefits to the stream. On the left, rotational grazing management or adaptive grazing management. You can see cattle in this paddock and they're being moved around in different paddocks. So they take grass down for a couple of days, they move frequently, and they allow that grass adequate rest. So again, they can maintain plenty of top growth. So they have big healthy root systems to improve the soil, alleviate compaction, hold moisture in the soil, and feed that soil microbe community and get more production out of it all at the same time. On the right side here, we have conservation cover. Again, an example of a grass strip or a filter area, areas protecting it, this cropland potential impact from the stream. And then at the bottom, a forested riparian buffer along the stream. So we're actually planting native trees and shrubs along the stream to protect it from adjacent cropland. So all good practices. Now here's probably one of the keys to any good soil health system where we're going to improve it. Diverse species cover crop and no-till farming. So no-till farming, eliminating the tillage from the system altogether. With today's modern machinery and herbicides or cover crop rollers, we can even do it organically today in some systems, but we can do very little disturbance. The only amount of soil disturbance we do is a slot wide enough to put the seed in and cover it back up. And then we have the soil armored and protected. In this case, this is a beautiful multi-species cover crop on a farm down in Northumberland County. You can see in here, there is sorghum Sudan grass, there are mustards, there's rape, there's kale, there's hairy vetch, buckwheat, all kinds of things in there that are providing diversity for that microbe herd or that microbiological community that we have under the ground that's cycling nutrients and helping stabilize the soil and adding all these benefits that we think of when we think of improved soil health. So diverse species cover crops and no-till farming are keys to improving soil health. There's 4 soil health principles that have been coined by some folks in NRCS a while back, and they have this like circle or wheel. They talk about the 4 principles of soil health. And again, these can be adapted to any kind of land system wherever you're at. You can do this. We need to minimize disturbance as much as possible in a healthy soil system. We need to maximize cover, so protect that soil. We need to maximize our amount of biodiversity or the diversity in the system, both in crops in that system as well as cover crops. And we need to maximize the amount of presence of living roots. So have living roots as much as possible throughout the year. If you have a bare soil, you essentially have what a local agronomist friend has coined as a sunshine spill. You're missing out on an opportunity to gather sunshine, to allow photosynthesis to occur and feed your soil microbes and improve the health of that soil. A couple fun facts. These are some things NRCS put together, but healthy soil is made up of about 45% minerals, so sand, silt, and clay in different varying amounts based on the soil texture. 25% of that soil makeup is water, 25% is air. So the air and water space, the pore space in a good healthy soil is 50% of that. So if you think of healthy soil, I like to describe it as if you think about marbles in a jar, there's plenty of pockets of places for air and water to go versus maybe Portland cement mix in a jar. Portland cement mix would be degraded soil with very little structure. You don't have those soil aggregates and it's not going to pass much air and water through there. You're not going to have healthy of a soil. 5% of the soil can be made up of soil organic matter, and that increases over time. You'll see soil organic matter is anywhere from 2 to 5% in our area, depending on how biological of a system there is, how much diversity there is, how much green plants they grow in there, and how big of plants they grow that have big healthy root systems that die back and help to increase that organic matter level. So some other facts that kind of led me down this path of thinking, hey, maybe we can really impact flooding and water quality in our area. On the right is a picture of a watershed, right? We all live in a watershed, and water through rain is caught up here in the hill, and it either has to infiltrate into the soil and filter through slowly, or run directly off if we have poor soil health or soil quality, and down through this stream and maybe potentially cause excess flooding. What I think we can hopefully do through these improved management practices to increase soil health is get more of this water in the ground up here in the watershed so it doesn't ever make it down to here to the bottom to actually cause excess flooding. But this was pretty cool. We talked about organic matter percent. And soils can be in our area, you know, anywhere from 1.5 to as much as 5% organic matter. But for every percent of organic matter that's in that soil, we can hold as much as 25,000 gallons of water, or about an inch of rainwater in that soil. So think about the impact of improving the soil organic matter in our soils, even 0.5%, how much more water we could get into that soil and hold into it, not only to reduce flooding, but also to improve crop production through those dry periods in the summer. So it can have a huge impact by making soil health improvements on our environment and our cropping systems. So I talked a lot about green plants and why they're so important and living roots, but this is why they're important. If anybody remembers high school biology and college biology, you'll remember the photosynthesis equation, right? The plant takes carbon dioxide out of the air. It takes water from the soil. It takes the sunlight energy, right? There's that free energy that we talked about, a sunshine spill. If we don't have a green plant growing, we can't take that sunlight energy. Photosynthesis happens, and out the other side comes C6H12O6, or sugar, And oxygen is a byproduct that's released back into the atmosphere. But that sugar, the plant takes what little sugar it needs or carbohydrate, and the rest of it leaks through those root hairs or is exuded through the root hairs, and it feeds our soil biology. And carbon is the key here. That's what the soil biology needs, is carbon. And when we think of a healthy, well-aggregated soil, what color do we typically think that soil is? Dark, right? Dark brown. Well, what color is carbon? It's black. So usually the higher the organic matter content, the healthier the soil, the darker it is. So by growing green plants as much as the year as possible, we're capitalizing on putting as much carbon into that soil as we can, thereby feeding our soil microbes, and they help us break down organic matter, increase the organic matter level in the soil. They help us infiltrate water better and use water and nutrients more efficiently in that soil to make our plants healthy and vigorous and higher yielding. All at the same time, while that above ground biomass gives us that soil armor protection to reduce against erosion, provide weed suppression, and all kinds of positive benefits in a cropping system. So keep in mind, the green plants and the continuous living roots, incredibly important. It's all about these bugs and that underground herd, and they've got to eat. What do they eat? They eat carbon. How do we get carbon in the ground? We grow big, healthy plants as much as the year as possible. The bigger that plant is, the bigger the root system, the more impact we're going to make on our soil health. Just a quick diagram. This came out of some old research on prairie lands, but take a look at a couple of things here. We want to maximize our biodiversity, but look at the biodiversity and the difference in the structure of the plants on top of the ground, and then look at their root systems, okay? So it's important for us to grow a variety of crop plants in a rotation, and it's really important for us to use multi-species cover mixes because we'll have some plants that are shallow rooted and some are deep rooted and some are tap rooted, and we really can capitalize on moisture and soil microbes and nutrients from all across the soil profile, versus if we have only this plant right here, we'll only use a small amount of the soil profile and we're missing out. Really like that photo. So what are some of the management practices we can do in modern agriculture, or in your garden for that matter, to capitalize on this? Well, we want to maximize cover. And what I'm showing here is, here's a multi-species cover next to Jen. She used to work here at the district in Columbia County. Look at the amount of biomass on that cover crop. Plenty of soil armor. Think about the roots that are growing in there, and the microbes are being fed and the nutrients cycled. Here's a picture of really farmers making it work and putting cover crops in the ground late in the season and getting them growing, so in the spring they have a benefit. You can just barely see these little cover crops. The point here is the farmer didn't give up on planting the cover crop even when it was late. He spent the time and found the effort was in there. In the spring, here it is. It's just barely coming up, but it gets to be really big. Here's some other cover crops. Here's a technique that has really made us be able to increase soil health quickly. This farmer, if you notice, is running a corn planter right through this tall rye and mixed species cover crops. That's something we've termed as planting green. Instead of killing that cover off early or plowing it down before they plant it, they're planting right into the live cover crop. This allows us to grow that cover longer, to maximize that continuous living root, and to maximize the height of that biomass on top ground, so we can maximize the amount of root mass we have that's really going to improve that soil health and feed those microbes quickly over time. So planting green and no-till farming and cover crops all together really are some management practices that can help us with improving soil health in a hurry. Here's another example of planting green. This is grain corn being planted into a stand of clover in the spring when it was green. And again, it's maximizing the amount of time that we can allow that plant to grow. Here's the aftermath of planting green. This was grain corn. It was planted into cereal rye and triticale, maybe a little clover cover crop, but you can see the height of that biomass in that stand to help protect that corn crop from weeds. And then look at the root mass on this cover crop. The roots coming down through there in that nice, dark, beautiful soil, holding soil moisture in there. This is a cool picture here. This is a piece of soil out of the same field up here where the corn is. And we put pink septic tank dye down in there, and it ran through, and look at all the pore spaces where water and air gets through there and all the roots, and it dyed all the roots pink, okay? Really important to have healthy soils and that good pore space and aggregate structure. Here's some of the tools that can help get this done. Folks are starting to use cover crop rollers, and here's just a couple different examples. Here's a cover crop roller that the district owns. It's just a small 6-foot demo unit that's pulled behind a tractor or a horse even. Here's a cover crop roller that's put on the front or the back of a tractor. And here's cover crop rollers that are put right on the corn planter unit. So imagine they're planting crop into large 3 to 5 foot tall cereal grain cover crop, and they're actually rolling that crop down on the ground to get soil surface contact to kill the cover crop in some instances, but to suppress weeds, to provide soil armor so it protects it from rainwater and erosion, and keep water in the ground in the hot, dry summer to improve crop production. So just some tools out there that can help us through this. These are cover crop rollers, and we're starting to see more use of that. Here's some pictures of this planting green technology that I talked about that, again, helps us to have big plants that have big roots that maximize the amount of time the plant is green, because we're not killing it before planting. We're letting it go right up to the day or sometimes 5 days after we plant it, which allows us to put more carbon in the ground, feed our microbes, cycle nutrients, improve the aggregate stability of the soil, improve infiltration, alleviate compaction, all these things. This is an example of rye and hairy vetch. You can see the little hairy vetch flowers in there, and you can see right here where the corn planter went through. We were actually planting pumpkins in there. You can see the planter going through, and then this is what it looked like afterwards. We had beautiful pumpkins that year. Here's planting soybeans into rye cover crop. Just another example of what this looks like. I'm not going to play that whole video, and I'm sorry if I made you seasick. It's hard to film with your phone while driving the tractor, but we planted soybeans into that crop that was probably almost 5 feet tall. The planter goes right through it, but look at the amount of soil armor left on this field. Almost impossible to get soil erosion to occur. And then this is a couple weeks afterwards as the soybeans emerged. Look at the amount of residue cover on the ground, the armor protecting that soil surface in there, and shading the soybeans and keeping the ground cool and moisture in there. So that we're allowing ourselves to maximize the presence of living roots. Again, one of these soil health principles that's helping us improve the soil health in a hurry. So here, now we're moving out of this degraded soil system, and we're really starting to think about improving soils. Up here, you've got corn that's planted into a cereal grain cover crop. It was planted green. Here's some folks looking at that, and some farmers teaching each other about that at a field day about how we do it. But take a look here on the bottom right.
Hey, Chris, I don't think your screen forwarded yet. We're still looking at you planting soybeans green.
Oh, sorry.
There we go. Yep.
So here's some folks building soil. At the top left, we've got planted green. This is silage corn planted into a green cover. Here's some folks learning farmer to farmer education. This is a field day we had a couple years ago. On the bottom left, can you guys see this dark streak coming down through there at the bottom of the knife? Take a guess what that is. I wish we were in the classroom. I'd show you this. That's an earthworm channel, okay? So let's skip over to the right side. Here's that same soil. Look at that deep, dark brown, again, high in carbon, dark topsoil layer. Those earthworms are coming up through this channel, and they're taking residue and shredding it, and they're bringing that topsoil back down through here and into the soil. They're bringing nutrients up, and they're cycling them, but they're also building that soil down through the profile. They're slowly over time increasing the carbon content, the aggregate stability, the structure of that soil, and improving that soil over time. And we're able to do that because we're feeding the soil and the soil underground herb, the microbiology there, with carbon by growing green plants and protecting and armoring that soil. We've maximized living roots. We're increasing and maximizing diversity. We're minimizing disturbance on the soil surface. Earthworms are a key part of healthy, and middens are some evidence if you're looking around in the garden or a crop field of that. On here in the red circle, these are called middens. You can see all this crop residue pulled in a pile like that, and you'll see this if you look. That's what the earthworm comes out at night, and they're pulling all that residue from the surface down into the ground to start shredding that material up into smaller size, so then the bacteria and the nematodes and the fungus can all go to work on it and release those nutrients in it and cycle it and make it part of the soil profile. Here's just an example of an earthworm hole. A lot of roots can go down there. A lot of water and air can get in there for healthy plant growth. Here's another example of middens, which are these little like byproducts. This is what the soil after the earthworm passes it through it, but you can also see them pulling this residue right down in the hole. So something to look for. I mentioned earlier, do we have a runoff issue or an infiltration issue? Probably we have an infiltration issue, and here's just a quick example. We went out in this field to the left. This has long-term no-till, multi-species cover crop. There's a 3 or 4-way mix of cover crop in there. This was in February a couple years ago, and I pulled these soil trays right out of the ground, okay? So here's that field on the left with multi-species, no-till, cover crop. Here is, on the right side, a field with corn, soybean, wheat rotation with tillage. And this had a little itty-bitty clovey cover crop in it, but it had a lot poorer of a soil health condition, more compaction. We simulated an inch of rainfall on this, and then we collected the runoff. And it's a little bit hard to see here, but there was 30% less runoff off the surface of that healthy soil with the multi-species cover versus that less healthy soil with the tillage in the system. Look at the difference in the runoff and the cloudiness of the water. Think about that in a flood, the nutrients that are in that, the sediment, what we could do for water quality. If you looked at the trays underneath this, guess what? This healthy soil infiltrated a lot more water. The unhealthy soil with compaction, not as much. So just an eye-opening result. And then finally, just to finish this up, we got to tie all this together, right? So we want to manage this interface between the cropland and the stream. And a lot of these farms, we have streams. And this is an example of a farm out towards Namibia where we did some work with the landowner and the farmer. And we took this eroded stream bank here that just kept losing soil back and back. And we did a project and we worked with Dave Keller and some local contractors, and we put in mud sills and cribbings. We protected the edge with logs, and there's rock back under here to stabilize it. We graded it back, seeded and mulched it, and put some willow seedings in there. We put in a stream deflector to push water out away from the eroded corner. And I don't have it in this picture, but we did end up planting a forested riparian buffer back in here in this wedge, and out around the edge of this, we put a 50-foot buffer. So we really tried to tie all that together. And this same farm, we had multi-species cover, we had planting green, we had no-till, we had all those practices on the land, doing everything we could to improve the health of the soil, get more water in the soil, get more carbon in the soil, fully utilize our soil microbes, improve the health. And then we repaired the stream here in a alternative manner to riprap. And then, you know, I just showed here, you can look at how this works. Water comes down here, it hits the logs.
Looks like Chris lost.
Patrick, did I lose you guys?
Yeah, just for a second. You're still a co-host though, so you can reshare your screen.
I'm sorry about that, guys. We have, that's our internet that we have here. This is almost the last. Let me know when you can see it.
Not yet. Okay.
So are there any questions? And I just put here, I pose a question or what I think to be the truth, that healthy soils really are going to ultimately equal clean water and healthy streams. And there's lots of simple solutions that we can do out on the landscape, whether it's in the garden or in the forest or on our farms. The solution, or part of the solution, really is pretty simple. Plants fix the soil. So we need to grow plants, and we need to figure out ways to incorporate them in more of our systems as much as we can. Here's just the final thing. This is a runoff simulation. Again, this is an inch of rain simulated over these different farming type systems. Here's conventional tillage, no cover crop, poor soil health, poor aggregate stability. Here's no-till with covers. That was that planted green field you saw a while back with the corn and the standing small grain residue. Here's rotational pasture, and here's conservation tillage, 30% residue. Look at the amount of runoff in these systems. tons of it here in conventional poor soil health, tons of it here in conservation tillage, poor soil health. Look at the good soil health and the heavy armor, almost none, and it's crystal clear. So I'll just leave you like that, leave it with you there. We can make huge improvements, I think, in water quality and the health of our soil, and a whole bunch of other things, farmers' profitability, with some simple management things, all tied around soil health. So thank you for your time. Were there any questions, Patrick?
Sure. Yep. We do have one question came in from Paul here. I'll read it off. I had a small acreage in crep a few years ago, and it wasn't approved. Went up for renewal. What can I do to find out what is available and if anything has changed in the requirements? I currently only mow it once a year to replicate a crep program.
Mm-hmm. I'm not sure if it's in, as far as it goes for crep, I don't know why it would have been marked ineligible. It probably might have had to do with how steep the ground was. Early on, crep allowed some land in that wasn't as steep as what's now required. They're now looking at more sensitive land, which have a little bit steeper grade to them. As far as getting it back into crep, if there's already a decent grass cover there and there's no lack of erosion or environmental quality problem, it's probably not going to be eligible for crep. We could talk maybe offline if you wanted to reach out to me at my office at some point. I can have Patrick give you my number and we can talk about other options that might exist.
Okay. We have another question in here from Cynthia. I rent out 4 acres to a farmer. He uses no-till but sprays Roundup on it every year, then plants Roundup ready seeds. Is it possible to just roll it and not use Roundup?
It is potentially possible to do that. It probably would take some transition, and it would be something that you'd have to chat with the farmer with and see if that's something they could do within their management system. It definitely could be done. It takes a little bit of time. It's a little bit of an art, and the farmer has to learn how to do that. But yes, it could be done. You have to make some management changes there. You have to grow a big, tall cover crop. You need a cover crop in there like a clover and or a small grain crop, and that crop has to grow long enough to get to a mature enough state where a cover crop roller would actually kill it. So the long and the short is, yes, it could happen, but it likely would have some kind of transition period. And if the farmer is interested in that, if you say something to him, myself or my staff would be more than willing to at least talk through the system with them and you and figure out how they could make that transition if they wanted to.
Okay. That's all I'm seeing at the moment right now. If anybody has any other final quick questions, feel free to get them in. But if not, again, you always feel free to contact anybody here at the district or NRCS if you have existing or further questions. Not seeing anything else. So with that, thank you guys for coming. Kris, we appreciate you coming down and giving this presentation for us.
Yep. Thank you all. Have a great weekend.
All right. Thank you all. Take care.